Our next teacher was first introduced to Bitcoin in 2015 while leading growth marketing at a virtual reality company. She graduated from University of Utah in chemistry and marketing. Beatrice speaks 5 languages. Pig Latin is not included in that. She's a med school dropout. She is a product manager at Radar, building ION, the homepage of Lightning Network. It's my great pleasure to introduce Beatrice Leung. Is that how you pronounce it? Yeah.
All right, how are we doing with audio back there? Can you guys hear me okay? Awesome. Thank you again, Angie, for the introduction. Thank you all for coming to my session on joining the Lightning Network. Today, our session will be 2 parts. So the first part of this, we will go over kind of the Lightning Network basics, an overview of what the Lightning Network is, and give you an idea of how you could go about setting up your wallet, some of the need-to-know things that we want to get out of the way before we start our demo session. So that, I'm thinking, will take roughly about 20 minutes, and then I'll open that up to questions from the audience, and then we'll do a quick 10-minute break, and part 2 of the session will be a hands-on demo, so we'll go through and have you guys set up a Lightning wallet of your own. That process can take anywhere from 45 minutes, if block times are in my favor today, or 2 hours. So due to that, for part 2, it is completely optional. If you'd like some troubleshooting on how to set up your wallet, I'm more than happy to help. So without further ado, let's go ahead and dive in. With a raise of hands, how many of you are familiar or know about the Lightning Network? Okay, awesome, cool. So about half of you already know a bit about it. So let's just dive into what you should expect from this presentation. So we're going to keep it pretty high level. I'm not an engineer, so all of these will just be more around explaining the network, understanding how to utilize it. For the purpose of this presentation, we won't dive into anything like changes to layer 1 in terms of Bitcoin scaling as a solution, so please don't ask any questions around why can't we change the block size or the block height. We won't be doing that today. And then another aspect is regulatory. So I don't have any type of regulatory training, so we won't dive into that side of things either. And all of these topics mentioned in the presentation definitely could be expanded on. I'd love to have an hour session where we can jam out on HTLCs, but that's not the forum or the class that you signed up for today. So we'll keep everything very high level. We won't dive into the nitty-gritty of the technical details, also because I'm not an engineer. Cool, so let's get started. All right, so I wanted to start off with the Bitcoin's scaling problems. So as you all know, as the activity within Bitcoin rises, the cost to transact and transfer funds within the network also follows suit. So it's making it quite difficult for the Bitcoin blockchain in its current form to be scaled as an everyday payment system. This is a trade-off that we're well aware of when designing the Bitcoin network. So with the proof of work system operating via global consensus ensures that Bitcoin's security and decentralization components of it, but it leaves the network slow and costly to transact. So when the network is really congested, fees for sending just a small amount of Bitcoin don't make sense. While many developers are working on layer 1 scaling solutions, both on the hardware and the software side, there are a lot of constraints that come with that. And so that's leading us to layer 2 scaling solutions. Bitcoin's capacity is often compared to Visa credit card network, which processes up to 300 times as many transactions as Bitcoin does on a daily basis, and up to 10,000 times as many transactions in a day. But even with Visa's level of sophistication and capacity, it would still be insufficient or costly to support a lot of the ambitious visions that we have for digital payments. So paying per API call or micropayments on the network are still not doable due to fees. And that's where layer 2 comes in. The layer 2 approach suggests that small and everyday transactions don't have to be stored on the main blockchain. So we're avoiding the 7 transactions per second limitation on the Bitcoin blockchain, and with an off-chain component, so an off-chain trade-off. Layer 2 technologies enable cheap and instant payments of any sizes, and it can scale to billions of users. It can also be applied to most existing blockchains. So today we'll specifically touch on Bitcoin, but this has been applied to other chains such as Ethereum. Layer 2 technologies also enable trustless cross-chain exchanges, and it currently works today. So I can make a Lightning payment to any of you if you had a wallet set up. So what is the Lightning Network? In short, the Lightning Network powers nearly free and nearly instant Bitcoin payments. It's secured by the Bitcoin blockchain, and you can pay other Lightning Network users and hundreds of Lightning-enabled sites without handing over control of your coins. Your Lightning wallet means your Bitcoins. Let's go one click deeper on what the Lightning Network is. So the Lightning Network is a permissionless peer-to-peer network of thousands of nodes, and nodes can be in the form of computers, phones, point-of-sale systems, that complete a Bitcoin payment from one node to any other node in the network within seconds with negligible fees. So nodes arrange themselves into a mesh form by forming two-party agreements called payment channels, which you'll hear a lot about in this presentation. And nodes that are directly or even distantly connected by this web of channels can exchange payments by routing through the nodes and channels that connect them. So a quick video that I have here will show you. Let's see if I can get this over here. Oops. All right. Let's go here. I don't think that video is going to work, so we'll just go ahead and move forward with it. So the idea is that one node hops online, you're connected to another node, and you have one channel open, but that's just one glimpse of the network. So through payment channels, you get access to all of the nodes that are online if you are connected one that has connections to others. So there are multiple client implementations of the Lightning Network today. Some of the popular ones are LND, C Lightning, Eclair, and they all operate on the same standard of peer-to-peer payment networks and follow a set of specifications known as the Bolt specification, but they all differ in usability, in functionality, and feature set. All right, so with the value props of the Lightning Network, the key value propositions for the Lightning Network are that all the payments are final, private, fast, and cheap. So there are no mechanisms to reverse successful payments. Like we mentioned earlier, this is on top of the Bitcoin blockchain, so all of the security features that come with the Bitcoin blockchain, Layer 2 Lightning Network inherits that. And so there are no mechanisms to reverse successful payments. Only you and your peer can view your off-chain transactions. So if I have a channel open with Gareth, you guys can't see any interactions that we have other than when we enter the network and when we exit the network. Payments happen as quickly as your wallets can communicate. And I preface that because depending on your internet connection, it could be a second, it could be a millisecond, it could be faster or slower, depending on how quickly your wallets can communicate with each other. But for the most part, Lightning Network payments are instant. Routing fees are also often free or a fraction of the cost of on-chain transaction fees. We won't dive into HTLCs too much today, but with the Lightning Network, there are a lot of interesting payment structures that you could explore. So utilizing pre-images and HTLCs, you create a new, different type of payment structure that will allow conditional payments. Additionally, it inherits the security propositions of Bitcoin blockchain, so censorship resistance, immutability are all of the things that the Lightning Network gains from building on top of the Layer 1 blockchain. Global payments to any party on the network, as long as there is a route possible. So again, back to the immutability, censorship resistance, and really the network effect of Bitcoin, it doesn't matter where you are, and it doesn't matter where you're located. We're able to send you payments as long as there's a route within the network. All right, so some of the use cases that we see today is far beyond supporting millions of people paying for coffee with Bitcoin. That's often one of the analogies people go to, but there are so much more that we can do with the Lightning Network. Micropayments open up an entirely new frontier for us on the payment side, because like we mentioned earlier, it's not doable right now with any of the payment processing infrastructure that we have in place. So the transaction fees are simply too high to be able to afford a continuous micropayment structure. So with this, with the Lightning Network, we're able to accomplish instant global payments. My family is originally from Hong Kong. I'm currently residing in the US. If I want to send money over to my mom right now in Hong Kong, there's about a 3-day wait if I went over to a traditional banking side. There are other services that will allow me to do that instantly, but the fees are really high. So for me to send a wire to her that would happen within an hour would take me 8% of whatever I'm sending over to her. With the Lightning Network, that problem's solved. As long as I have a route to her, she has a Lightning Network wallet, we're able to get instant global payments. You can also pay per content, which I think is a fascinating area for creators online right now, which is each video that you stream, the users can pay per content that they're streaming. Additionally, any type of articles that you write, instead of having a subscription to your entire publication, users can now pay per article that they read. Additionally, you can tip people across the world without their banking information. That's also one of my favorites, which is tippin.me on Twitter is a great Chrome extension that allows you to tip anyone on Twitter with Lightning payments. So I don't have to ask them for any of their banking information just to give them a kudos. And you can also stream APIs with micropayments. So if you want a specific data feed, you can subscribe to that via Lightning Invoice and continue to stream data off of it rather than getting an entire compilation of all of the data. And you can also buy pizza with Bitcoin. So there are definitely limitations within the network. It's still very young, and some of the constraints involve routing. So nodes must remain online to send, receive, and route payments. Additionally, liquidity management. Users are required to closely monitor sending and receiving capacity to utilize the network. And so, as a user on the Lightning Network, when you want to go and send or receive funds, you do have to pay close attention not only to your wallet balance, but also if your channel itself is balanced, which we'll dive more into later in the piece. Channel sizes within the network are also limited depending on the implementation. And then also there's limited tooling for things like accounting, treasury management. So if any merchant or business wanted to dive into the Lightning Network today, these tools and the foundation is still being built. There's also quite a complex UI. So going into LND right now, you have multiple interfaces that you can go with. So a GUI is one option, but oftentimes people are still working within command line, so it's not quite as user-friendly. Additionally, like I mentioned earlier, the onboarding process could take us anywhere from 45 minutes if we're lucky, or it could take up to 2 hours for you to set up your Lightning Network wallet. So there is a time constraint component to setting up your wallet. All right, before I dive into that, do any of you have questions around kind of the value props or the overview of the Lightning Network? Great. All right, so we'll dive into onboarding basics. So there's roughly about 6 steps to get you started on the Lightning Network. First, we start off with downloading a wallet. Wallets come in many shapes, sizes, and different forms. Once you download a wallet, you have to set up a password and also a seed phrase. Once that is done, it will sync the blockchain and Lightning Network data. This also comes in many forms. So with Neutrino, it could take less time. If you sync the entire blockchain, it could take you a few days. Then you fund your wallet. So for our demo session today, we'll be funding our wallet with a testnet faucet. So we'll be getting some testnet Bitcoin. And then you open a payment channel, which again, the confirmations, it requires 3 confirmations. So that could take anywhere from 30 minutes to 45 to an hour. And then you can pay a Lightning invoice. So once this is set up though, once the onboarding basics are done, your Lightning Network is good to, or your Lightning Network wallet is good to go. You can transact with as many apps, with as many sites as you'd like with that same wallet. if you have the available balance with it. So keep in mind, while this portion is time consuming, you don't have to do this every time. All right, so within the presentation, we talk a lot about nodes and wallets. So every Lightning Network wallet is a Lightning node. Every Lightning Network node is also a Lightning Network wallet. For the purpose of this presentation, for all functional nodes at least, there are no differentiations between the two. So you'll hear me kind of use the words interchangeably. And I mentioned wallet options come in all shapes and sizes. Some of the popular options are a desktop wallet, which we'll be going over that today, mobile wallet, and within the desktop wallet, you have a GUI, you have a CLI, you also can access a desktop wallet just on the web. On mobile, there's the option for on-device, or you could remote access into a node that you already have. So that node could be set up on the desktop, on a hardware device, and you just use your mobile device to remote access into it. Additionally, there's also dedicated hardware options. So the Casa node, an HC1 Droid, a Raspberry Blitz are all just microcomputers that can run L&D on them that are dedicated hardware just for running your node. And that's often an option people like to use for a routing node because there's good uptime, you're hardwired into the Ethernet port, you have a continuous power source, so you're always online. And any computer device that you can load a daemon to, which are the client implementations, you can essentially set up a Lightning wallet. Also, any cloud that you can deploy a daemon to, you can also get a Lightning Network wallet set up. What we won't dive into is kind of the custodial and non-custodial options within these. Each one of these options offer a custodial, which if you want to entirely have control over your Bitcoins, that's the non-custodial route is for you. If you are willing to sacrifice some of the trade-offs for the convenience factor, custodial nodes are also an option. Cool. So we mentioned the layer 1 and layer 2 aspect of this network. So there are times where your transactions will happen on-chain. The two times that they happen are, one, opening and closing transactions are done on-chain. So when Alice and Bob start their channel, they will have a opening transaction, which is also called a funding transaction. And when they're all settled, they've made their transactions on the Lightning Network, everything's done off-chain. When they want to settle out and kind of close that channel up, they do so on the Bitcoin, on the layer 1 Bitcoin chain as well. Opening and closing a channel. So bidirectional funding of channels are not yet available. So if Alice and Bob were to open a channel together, only one party can deposit funds into that opening channel. So it's either Alice or Bob deposits money into that channel. In the future, bidirectional funding of channels will be possible, so Alice and Bob could deposit money at the same time. So opening a channel requires at least 3 on-chain confirmations that we mentioned earlier, and this is why there is a little bit of a ramping up period, if you would, for when you set up your Lightning Network wallet. And when you close a Lightning Network channel, there are 2 ways that you can go about it. It's either a cooperative close, so both peers agree to the channel state and sign the transaction. So Alice and Bob have their channel open. Alice says, hey, I think it's time that we close this channel up. We've settled all of our numbers. And Bob says, yes, the channel state that you just gave me, that looks good. Let's both sign off on it. We shake hands, we part our ways. There's one scenario, though, where that's called a forced close, or also known as a unilateral close. And that's when, let's say it's over the weekend, and Alice is like, hey, Bob, I want to close out this channel. Bob's offline, and he's out snowboarding. He's not available right now to confirm the channel state. So Alice says, I want to close this channel immediately, and Bob can't confirm what the balance of the current channel is, so also known as that channel state. So funds are locked up depending on the channel policy, which is determined when they first open the channel. So Alice and Bob said, hey, we're going to wait 3 days if we don't hear from Bob before we go ahead and force close this channel. And And so with that channel policy in place, you could wait anywhere between a day or 14 days. So Alice, again, with this scenario, Alice says, Bob, I want to close out the channel. Bob won't be back for 3 days. 3 days later, when he comes back, the funds are locked up, and Bob says, yes, this is the right channel state, let's go ahead and close it. Or if Bob never responds to Alice again, that's a forced close. And so if Alice is honest and she actually broadcasted the appropriate channel state, which is the most recent one, then there will be no breach remedy transactions, or she will get the funds and the channel will close out, depending on the channel policy. But should Alice actually be dishonest or fraud in any way, and she broadcasted an old channel state where the balance was in her favor, and Bob didn't take any action against this, so the breach remedy transaction would protect Bob and say, hey, this is not the most recent channel state, and Bob can broadcast what he has in his books, essentially, and say, hey, Alice, this isn't right. I should have more money than this. The network is set up where all of the funds within the network would be sent over to the honest party, which would be Bob. All right, so let's dive into sending and receiving a payment. So like we mentioned earlier, nodes need to be online. Nodes need to be online in order to send, receive, and route funds. So sending and receiving a payment requires your nodes to be connected to other nodes within the network. It is a peer-to-peer network, after all. And thus, step one, after you have a wallet and funds in the wallet, you have to open a payment channel. So again, Alice and Bob opened a payment channel. Go ahead.
Can you describe what actually happens in the Bitcoin network when you open a payment channel? What's actually going on there?
Yeah, so when you initially open the channel, that's an on-chain transaction. So on the layer 1 chain, you're able to see wallet A and wallet B have this many funds in each of them that they sent each other.
So there's an input and an output?
Correct. And after that, there's nothing else that you can see in the network until that entire channel is closed and settled, essentially. And that's when the off-chain or the on-chain transaction of the close will be broadcasted. Correct. Yeah. So there's essentially 2 points within the network where you can actually see activity between these two wallets, which is during the opening and the closing transactions. And so when you're sending and receiving payments, in this portion, we're already going into the off-chain component. So let's say we've already opened a channel. Alice and Bob already have their channel open. Everything else in between is them sending and receiving back and forth between each other. And the beauty of the network lies in the network effects. If you'd like to send or receive a payment to someone within the Lightning Network, you do not need a direct channel with them. So a lot of the questions that I get asked is, hey, I want to pay my local coffee shop. I want to pay my internet bill. I want to pay a peer. Do I have to have a direct channel open with each of them? Because then I'm locking in funds with each party. So how does that save me on-chain fees, right? Because if I open a channel to my coffee shop, ching, I'm paying on-chain fees there. If I open another channel with my internet provider, that's on-chain fees there, along with my peers. So with the network effect, you don't need to have a direct channel open with everyone. Let's say my coffee shop has a channel open with my internet provider. From me opening a channel with my coffee shop, I now have the ability to pay my internet provider because my coffee shop will route that payment for me. So payments can be routed through other peers within the network. If needed, a payment can even be routed through multiple nodes to reach a destination. So let's say I need to pay Bob. Bob's connected to the internet provider, who's also connected to the coffee shop, who's also connected to me. I now have essentially 3 hops before I get to Bob.
Sorry, so on the blockchain, what
Yeah.
would that coffee purchase look like?
On the Bitcoin blockchain. So there would only be an opening transaction where I lock up funds with the coffee shop and we have a channel open. From there, if I use that coffee shop's node to route my payment to my internet provider, there is nothing that you can see on-chain. Let's go ahead.
So on the routing, if you have the 3 hops,
Mhm.
how much does that increase the processing time?
Yeah, great question. So in the beginning, when your wallet is looking to, so let's say I'm looking to pay you, but there's 2 other hops in between, your wallet will actually construct a route first and look at kind of the uptime of the node, look at if the node, make sure that the node is online, so when you're routing through it, that the payment can be successful. And it does not decrease the time for the transaction. There are instances where your payments could fail though. So let's say we have those 2 hops in between. I'm online, you're online, but the 2 hops in between are offline. So when the wallet is constructing that route, it's seeing that it's likely going to fail because these 2 nodes are offline. That's when it's going to cause a payment failure, and you're going to have to either wait for those nodes to come back online, connect to a better connected hub that can route you.
Doesn't it automatically do that though?
Pardon me?
I thought it would automatically do that.
It does.
Oh, okay.
Yeah, but then as the user, you have to decide whether or not you want to. So if you're, let's say you use a GUI and it comes back with an error message that says no route available, as the user, you have 2 options, right? You think, okay, is this person ever going to come back online? If I know them and I can just call up and say, hey, coffee shop, your node is offline, please come back online so I can route through you, that's one option. Or the other option is, as the user, you can say, hey, actually, the node that I'm connected to is not managing good uptime, and it's not really good and effective routing node, because again, in order to route, you need to always be online. So if you're not a reliable party, I'm locking funds with you, but every time I try to make a payment, it doesn't work. So it's your decision then if you want to close out this channel and open a channel with what you consider a more reliable party that has good uptime. Yeah, go ahead.
Liquidity requirements, you're sending a certain amount of Bitcoin through the Lightning Network. Doesn't every hop along the way have to have at least enough funds to route that payment?
Yes, great question. That's actually going to be the next slide. So perfect timing. Let's see. Where are we? Yeah, we'll dive into channel capacity in one slide after. So you'll often hear people talk about a hub or routing nodes, and by opening just one channel up, you can send, and if your wallet supports it, receive free and instant, nearly free, and instant Lightning payments to nodes across the network. So in this presentation, my definition of a hub is going to be a well connected to the graph, has liquidity to route payments in and out, also has high uptime and availability. There are a lot of debates around, is a hub centralized? Does that change the nature of the entire Lightning network and its usability? So those network graphs to the right there, you can see different layouts of what a hub looks like. For the sake of this presentation, we won't dive into kind of the decentralized component of it. All right, channel capacity. So now that we understand the basics of routing, of your payments, let's dive into the nitty-gritty of channel capacity. So Alice here opens a channel with her favorite game, Lightning Chess, which is actually really fun. We will try that later in the demo session. So she locks up an entire Bitcoin. It's very expensive chess games over there. So she deposits 1 Bitcoin into the channel, and Lightning Chess, again, they can't do a funding transaction together. So right now the balance would be Alice has 1 Bitcoin, Lightning Chess has 0 Bitcoin. And when you initially deposit funds into that channel, your sending capacity is what you've deposited. So Alice's sending capacity in this case is 1 Bitcoin. Lightning Chess's receiving capacity is 1 Bitcoin, because the party that did not put any funds in, their receiving capacity mimics that sending capacity of the other party. This can be a little confusing. If you look at the graph, you'll see 1 Bitcoin for Alice, 0 on Lightning Chess. This means that Alice can send Lightning Chess 1 Bitcoin, and Lightning Chess can receive that, but until the funds are moved over to Lightning Chess, Alice actually can't receive anything, because through Lightning Chess, there's 0 Bitcoin on the other side of the channel. So Alice opens a channel to Lightning Chess. Now that she has a channel open, she can play chess, almost. So Alice can send funds to Lightning Chess, but if she were to win, she couldn't cash out due to the lack of receiving capacity. Your receiving capacity is the sending capacity of the node you're connected to. Receiving capacity can also be referred to as inbound capacity or remote balance. So depending on what type of wallet you use, they may use different terminology. And your sending capacity can also be referred to as outbound capacity or your local balance. So when we talked about routing issues earlier, we mentioned payment failures. Payment failures are often caused by routing issues such as the node being offline or you have insufficient channel capacities. So in order to be a hub or a routing node, you have to have really good channel management of liquidity. So what that means is that the funds that you've locked into that node or into that channel, you need to have both a balance side on the sending side and the receiving side. So for example, if we go back to Alice and Lightning Chess, with this particular channel, neither of them would be a really good party to route through because one party has all of the receiving capacity and one party has all the sending capacity. So in a perfect world, if I could easily manage my channel, I would aim to have 50% of it be receiving, 50% of it be sending, depending on what you're looking to do with your node. If you're solely on routing and you notice that through you on one side, you are needing to push balance more, then you might change your channel balance to where 80% of it is receiving, 20% of it is sending, and et cetera. So you can change the balance or your capacity within your channel for whatever purpose you decide your node is for. Cool. I think we are now, how are we doing on time? 30 minutes, great. So now we can dive into some Q&A. Do you guys have any questions? Yes.
Back to this question about the value through, if you're always funding them from one side, and the other side is always going to be zero, assuming that you're funding it, the other side is zero. How do you change, like you change that balance through payments, like I have to send, like assuming we open the channel because I owe you something, right? So then I would send a portion to you through the channel, and then you have that increased balance that other people can see as a routing option?
Yeah, so let's use the coffee shop analogy again. So if I open a channel with my local coffee shop, I put a Bitcoin in, coffee shop doesn't put anything in. So all of the sending capacity is on my end. In a scenario like that, you're likely opening up a channel because you need to pay someone. So I need to pay the coffee shop. So every day when I'm getting my coffee, let's say for the sake of math, I've now have 0.5 Bitcoin that I've sent over to the coffee shop. Now the coffee shop one day messed up my coffee, I need a refund. That 0.5 Bitcoin that I've sent over, because now the balance is 0.5 on my end, 0.5 on the coffee shop end, so receiving and sending capacity are even at that point, the coffee shop now has the ability to send it back to me. But until I send any payments over to the coffee shop, they essentially don't have an option in this channel to send me anything back. So let's say you're a merchant, completely different scenario. You're a merchant A and merchant B want to do business together. There's going to be a lot of sending money back and forth, right? Not only one party pays the other. And so in this case, because the bidirectional funding channels aren't an option yet, you would just open two channels. So merchant A would say 1 Bitcoin on my end, 0 on your end. Merchant B, on the other hand, will open a channel back to merchant A, 1 Bitcoin on their end, 0 on the other. So now there's actually a channel that you could label. From merchant A, you could say, this is my sending channel and this is my receiving channel, so you can manage those two. Cool. Any other questions? Yeah.
Change the channel capacity. Does that go on chain? You have to add funds to that channel.
Yeah, so there are a few ways that you can add funds to the channel after the channel is open. So things like a submarine swap, which we don't dive too much into the technical, but you could essentially do an on-chain transaction to fund your off-chain channel. Additionally, you could do circular rebalancing. So I have 3 channels open, all of my channels are connected to each other. I want to change the balance of one, that will actually route back over a channel to the other. Those are some of the options that you could do if you wanted it to be off-chain. But if you want to actually change the balance, so let's say coffee shop and myself, 1 Bitcoin, coffee shop has 0. Turns out 1 Bitcoin isn't enough for my coffee consumption. I now need to add more. You would have to close the channel. If you didn't want those 2 options that I mentioned earlier, you would have to close the channel, reopen it in order to actually change the overall balance. So what you deposit into the channel for that funding transaction, unless you do a submarine swap, unless you do circular rebalancing, I'm sure there's a third option that I'm not aware of, but unless you go that route, you would have to close out the channel in order to actually change the balance within it. Yeah, of course.
wonder if you could talk a little bit about the potential criticisms of like the hub model and love to understand that a little better.
Yeah, definitely. So for this definition, we are defining a hub as really just a well-connected node, right? I know that I'm the internet provider. I know that a lot of people need to pay me, so I'm managing all of these channels, and I'm ensuring that channel capacity is good, which means liquidity is good. Because if I don't have any receiving capacity and I'm asking someone to pay me, that's a big no, because then they can't even get the payment to me even though I'm a quote-unquote hub. And so as the internet provider, you would want to make sure that you have both sending and receiving capacity very well balanced. Additionally, you want to maintain good uptime. So if your node, for example, this happens often with a mobile wallet. Every time you exit out of your mobile app, your node goes offline. So as an internet provider, you wouldn't want to do that as managing your hub, because every time you exit, your node's offline, people can't find you. And so more likely than not, you'll have a dedicated device hardwired into the Ethernet and power cord that makes sure that you have consistent uptime. Let's say uptime, liquidity management are the two biggest things. But the third thing would be just how well connected you are. It's a given that as a hub, you're well connected, but truly how well connected you are within the network to make sure that anybody within the network, immediately that they come online, they can pay you. That's easier said than done, because oftentimes Alice and Bob will just have a channel by themselves. And so if they're not connected to any type of other outside world and they just kind of have this channel isolated from the rest of the network, nobody can pay to them. So while the internet provider can make sure that they can extend as many branches as possible, if there are parties that kind of do their own thing siloed, then there's still a limitation from that isolated channel to get to the internet provider. Yeah, go ahead. Yeah.
So in that situation where Alice and Bob are kind of off by themselves, are their nodes still part of the entire PP network?
Yeah, great question. So they are definitely still part of the network. There are multiple ways that you can kind of set up your node. You can be one that gossips, which means that you're telling other nodes, hey, I'm here, I'm in the network. There is an option where you can basically say that you're a routing node. So then you're telling other nodes that, hey, I'm well connected, use me. Or you can even adjust your fees. I have low fees, route through me. Or you can say, I have really good reliability, so I charge a little bit of a fee because it takes time for me to manage my internet, manage my power source. So you charge a little bit of a fee, but people can route through you. And that's one way you can set up your node. So you can essentially say that you're a routing node. The other option is that you can just be a private node and say, I don't really want to route. I'm here on the network because I want to interact with Alice and really just Alice. So I don't have any other channels open. Please don't go through me to route. So you do have more private options available if you don't open a lot of channels. Also, another thing to keep in mind from a privacy side is that if any of the transactions that you do offline, people within the network, unless they are routing that path, and unless it's their immediate next hop, they don't really know where in the graph you are. So one way to think about it too is that if, let's say, back to that scenario where we had 3 hops, I only know my next hop. I don't know how many hops it actually took to get to him due to how the network is set up, onion routing, etc. Yeah, good question. I will go ahead and 2 questions. I will go ahead and answer yours first.
I channel with the coffee shop, but it's only 1 Bitcoin capacity, and I want to send 2 Bitcoin, and I want to do it through you. Can I do that still, or do I have to ask you to upgrade it?
Yeah, so we could zoom out a little bit here and think of it in a different way. If you were to, let's say, send 2 Bitcoin over to a different party, it doesn't all have to be through that one route. So if the coffee shop only has 1 Bitcoin in this route to send, you can break up the payments. Send 1 Bitcoin through the coffee shop, send another Bitcoin through another party, and get your 2 Bitcoin over. You just need to make sure, though, that you have 2 Bitcoin sending capacity within your channels, whether that's 1 Bitcoin split between the coffee shop, 1 Bitcoin split between Bob, or another Bitcoin split between your internet provider. It's totally fine. You can still get to the end destination as long as where you're going has kind of that path connected back to those channels. But you can split them up, so you don't have to rely on one channel solely. Although, depending on how you decide to set up your node, you may just have one channel open to a hub, put all of your money into that, and then let the hub kind of figure out the liquidity management for you. Yes, you had a question back there? Yeah.
I was just wondering if you could talk about the always online requirement. Is that something that's just a current limitation as a network as Lightning is in development, or is that sort of by design? Is there solutions to that that could potentially be out in the future? Because it seems like a usability nightmare to have an always online device and UPS backups and IC hard drive configuration. It just seems a little bit difficult for your option.
So I would answer that with saying it really depends on how you're planning to operate on the network. So if you are a merchant and you are going to be receiving large amount of funds, if you're a merchant that you are going to be sending a large amount of funds and you're constantly routing, it is a requirement that you're going to have to be online. So in this case, for example, it wouldn't work if I wanted to pay my internet provider, but I go on Comcast website and the website's down. So that node is essentially that payment portal. If they don't maintain uptime and they're not online, I can't pay them. That's one area. The other, though, is as a user, it's not a requirement that you're constantly online. It's mostly just for routing purposes. So right now, I have about 5 wallets set up on my phone, but none of them are actually online right now. Depending on which type of wallet you're going to as well, your wallet provider could actually be the node that is. You have one channel just to your wallet, essentially. So that's similar to how Breeze wallet is set up. So you have one wallet, or you have one channel connected to Breeze, and Breeze is the one that makes sure they're constantly online. They have good liquidity management. They're kind of doing the legwork for you, and I suspect that we'll continue to see a lot of wallet providers do that. Another popular one with Android is Eclair, so they have incredible uptime. They're one of the best managed nodes on the network right now, and so they take away a lot of the legwork for the user. But as a merchant, it's kind of just table stakes. You have to continue to manage good uptime and really liquidity management and usability. Cool. All right, so that we're done with the Q&A, we will go ahead and take a quick break. This is part 1. Thank you all for attending.